Hi, I'm Vincent.
Hi, I'm Jacob.
I'm Valerie.
I'm Christine. I'm Lucy, and we are the Marine Tag Team.
Currently, there are no existing effective non-invasive attachment tagging methods for rough-skinned marine animals. Our objective is to design a mechanism that will allow the tags to stick onto the skin of these animals in an unharmful way for more than 6 hours.
The purpose is to create a longer-lasting, non-invasive marine tag for rough-skinned marine animals to allow biologists and other research teams to gather more information on specific aquatic species and assist marine protection efforts.
This is our final design solution. The three primary key features of our design are the modified suction cups, the self-releasing mechanism, and the adhesive. For the suction cups, we decided to sand the surface and add holes. The purpose of this modification was to increase the physical bond between our adhesive and the suction cups to prevent the adhesive from remaining in the ocean when our device was pulled off the truck.
The adhesive we chose is 3M Marine Adhesive 4200 Fast Cure. We chose this adhesive because it is very viscous and it is a hydrophobic glue which is critical for underwater use. It also performed the most successfully during adhesive testing.
The last key feature we used is a self-releasing mechanism to remove the tag from the shark. To allow for a time-specific release, we attached the inner tag case to multiple springs that are secured to an outer case. Initially, the springs are kept compressed by PVA rods that prevent the tag case from rising in the water. When the PVA rods dissolve in the salt water, the springs are allowed to expand, creating enough force to pull the suction cups off of the skin of the rough-skinned marine mammal.
The primary materials that we used in our device were PVA and ABS plastic, springs that are 1.25 inches in length, 0.48 inches in diameter, and silicone suction cups that are 4.5 centimeters in diameter.
The two primary components of our device are the attachment to skin and attachment to tag. Our adhesive is administered to the surface of suction cups that are attached to the tag case through interlocking pieces. The case that encloses the marine animal tag is held within an outer case that contains our self-releasing mechanism.
Next, the springs are compressed and the PVA rod is inserted into the tag case.
After the tag case is secured, our adhesive is applied to the suction cups.
Once our device is prepared, the tag case is attached in the water onto sandpaper, which mimics the surface of shark skin.
Once our device is placed in water, the PVA begins to dissolve. As the diameter of the PVA rod increases, the time it takes to dissolve also increases. The PVA takes approximately 8 hours to dissolve, and it takes an extra 4 hours for the springs to push the tag case off the sandpaper. Our final design solution satisfied all of the constraints. The leading surface area was 2.7 inches by 4.3 inches. Our device floated to the surface of water after releasing from the sandpaper. The tag case remained successfully attached to sandpaper for 48 hours in underwater environments. The suction cups remained attached to the tag case throughout all of our testing. Our solution is non-invasive because it does not penetrate the surface of the skin.
In order to complete our project for a client deliverable, we need to find an alternative for our current adhesive. The 3M Marine adhesive performs very well underwater, however it isn't entirely safe for biological applications. More testing must be conducted on veterinary and surgical glues that are safe, but too expensive for the Engineering 101 budget. Also, we would like to make our case more hydrodynamic and conduct additional testing trials on the dissolution of PVA in order to ensure a more specific timed release.